All right, so factoring the difference of two cubes. Again, it might be handy to keep the formula around until you have it memorized. But again, it's always this pattern. If I have a cubed minus b cubed, well, if that's subtraction, then what goes in between a and b in the first factor is going to be subtraction. The first sign in the trinomial will always be opposite, and the last sign will always be plus. Please, please, please start memorizing it. I would start memorizing it now, especially because you're going to use it all the time. You're going to use it in high school, through high school, you're going to use it in college. So please start memorizing it. All right, so here is an example. Let's say I have 8x cubed minus, no, I don't want to use that one. Let's see, forget 8x cubed. Oops, I don't want that at all. Let's say I have 27x cubed minus 64. All right, so I want to find the difference or factor the difference of these two perfect cubes. So what I first want to do is I want to go ahead and rewrite these things so that I can see what the bases are. So I want to look at a base like a raised to the third power. So the cubed root of 27, again, might not be that easy to recognize, but it's 3. If you multiply 3 times 3 times 3, well, 3 times 3 is 9, and 3 times 9 is going to be 27. So I can rewrite 27 as 3 cubed, and I have still x cubed minus 64 is also not necessarily a very easy one to recognize, but 64 is 4 cubed. And if I were you, I would definitely be using my calculator to check the cubed root and see if something is a perfect cube. If you want to do that, it's not the hardest thing in the world to do. You can either look for the cubed root button, or you can just say put in 64 raised to the 1/3 power, and that you can take a cubed root by using a fractional exponent. All right, so now that we have those things written simply, let's just fill in our formula. We of course have a minus b, so the cubed root, that's the a, is going to actually be both of these bases here. So, and an easier way to see that might be if you think about the power to a power rule. For instance, if I had 3x and I raised it to the third power, that would be 3 cubed times x cubed. That means I can go backwards. Think about it. Use the symmetric property. That means 3 cubed times x cubed is equal to 3x in parentheses cubed. And let's just write that. Let's just write 3 cubed times x cubed in that way so it becomes more apparent to us. So 3x quantity cubed minus 4 cubed. Okay, so filling in our parentheses, well, our a term is going to be 3x minus, because we have subtraction in between our perfect cubes, and the base of 64, or the cubed root of 64, is of course 4. Then in our trinomial, we have whatever the a term was squared, so 3x squared plus our a term times our b term, so that was 3x times 4, and I'll just leave it as that. I will simplify it later. And then finally, we have our b term, which is 4, and we want to square that. And just to get everything nice and cleaned up for us, we'll go through and simplify everything that needs to be simplified. So I have 3x minus 4 can just stay 3x minus 4. 3x quantity squared, well, that can be rewritten as 3 squared is 9 and x squared plus 3x times 4, well 3 times 4 is 12, and I just leave the x, plus 4 squared, that would be 16. So this is how I factor the difference of two perfect cubes. So please try to keep your calculator handy, keep the formulas handy, and I want you to practice the work I give you, and please email me if you have any questions.